Alright, welcome. In this video I'm going to be working through AP Pre-Cal Homework 1-2. But before I start, I'm going to actually fill out this table that you can see on screen right here. And because I think that's going to help us, have a really systematic way of approaching these problems. Because I've already heard the feedback, you're having some issues with some of these questions, the way they're worded. And so I just want to give you the strategies you need to help you have success with those. So for each of these terms I'm going to describe it in terms of the graph of f, which I think is the terminology you're probably more familiar with. And then I'll also describe it in terms of the rate of change of f so that we can, reference back to this when we go translate back and forth. Okay, so for increasing, that's where the function is going up. So that's where its rate of change is positive. And I'm not going to justify, why we think these things. If you need that, you go back and watch the video, right, of the lesson. I'm just going to give you the facts here so we can get started with homework. Okay, decreasing. That's where as we move left to right on the graph's moving down. It's a negative rate of change. Concave up is where the graph is smiling. The function itself could be increasing or decreasing while it's concave up. What that means in terms of the rate is that the rate's increasing. And for concave down, we saw the exact opposite. Right, the graph was frowning and the rate of change was decreasing. A local maximum, or relative maximum, that happens at a place where the function goes from increasing to decreasing. Okay, so where the rate goes from positive to negative. And minimum, it's the opposite. Okay, and what I'm showing you in the drawings here is that the minimum can happen at a place where the curve is smooth or where the curve is sharp. Now, the difference in smooth and sharp curves is not something we have to worry about in pre-cal, just kind of planting that seed for next year. But, the rate of change is going from negative to positive. A point of inflection is a change in concavity. So on the graph, we'd see that as like a change in attitude. It would be like the graph going from smiling to frowning, or frowning to smiling. And these are just pictures of different ways that can look. In terms of the rate, that's where we're going to see the rate changing from increasing to decreasing or decreasing to increasing. Okay, but that's all. I'm going to just leave it at that and get to the problems. All right, so we're going to get started with y equals f of x is shown below. The graph of f has points of inflection at x equals 0 and x equals 3. All right, so I'm going to just label those right now. So x equals 0, that's right here. X equals 3, that's right there. A point of inflection, we just said, it's a place where the graph changes concavity, where it changes attitude from smiling to frowning, frowning to smiling. All right, so the first couple of questions are they're looking pretty straightforward. Okay, relative maximum, that's where the function goes from increasing to decreasing. But I think you already know that's what I'm talking about right there. The top of a little local maximum. We said. All right, so that's x equals 2. Okay, at what value of f, or where does f have a local minimum, or x value? Okay, that would be here and there, right? Because that's where the graph goes from decreasing to increasing. So that's x equaling -2, x equaling +2, and x equaling 4. Wait, no, not there was one of those, it was a maximum. Yeah, x equals 2 was a maximum. So x equals -2 and 4. All right, next it's asking, when is the graph of f concave up? Okay, concave up, that means on the graph we're looking for where it's smiling. Really, that's what I would suggest looking for. So that's going to be, okay, all throughout here. And up until the point of inflection, because we know that's where the concavity is going to change. Okay? And then again, I'm seeing like it's looking pretty happy right there if I put in a couple of eyes. Okay, so I'm going to say from that point of inflection on and beyond that the graph will be smiling, and that will be where the function is concave up. Label that in blue. All right, so concave up was where x was less than 0. And also when x is greater than 3. Now when it asks for concave down, that's going to be where the graph is frowning. I'm going to get a different color for that, I guess. So we'll say, well, I guess I usually use sharp eyes for that. It's frowning like that. And so that's going to be between 0 and 3. Now it's going to ask about increase and decrease. Okay, so increase is where, as we move left to right, the graph of the function is going up. Okay, so I'm seeing that happen from the minimum up to the maximum. Makes sense. And then after this minimum as well. Okay, those are places where the graph is going uphill as I move left to right. That's another way of saying it. All right, so f is increasing from -2 to 0 and 4 to infinity. -2 to 0 and 4 to infinity. You know, you can write it as an inequality, you can write it as an interval, we don't care, it doesn't matter. You just need to be able to recognize both types of statement in a multiple choice setting. All right, so the other one was when is f decreasing, and it's be pretty much, you know, every other time. So I might come down in here in purple, you know, highlighter those places where the graph is going downhill as I move left to right. So that's going to be when x is less than -2 and also between 2 and 4. So let's x less than -2 and between +2 and +4. So that's when f is decreasing. When is f positive? F is going to be positive anytime its graph is above the x-axis. So f is going to be positive wherever its graph is above the x-axis. That means here and and here as well. I was going to miss that. All right, so that's going to be where x is less than -4, between 0 and +4, and then when x is greater than 4. So let's see. Yeah, f is positive, and that's x less than -4. 0 to 4, but not including 4, because at x equals 4, it looks like f is equal to 0, and that's not positive. And then x is greater than +4. As far as less than or equal to 0, it's just going to be through here, and then also right there, because it's going to be equal to 0. So I'd say x equals 4, and from -4 up to 0. So -4 to 0, and also at the point x equals 4. When is the rate of change of f positive? Okay, so this is the type of thing that I want to be just like, you know, really intentional about. All right, so the rate of change is positive. And, you know, just this time, maybe not every time, but I am going to flip back to the reference grid. I see right here, rate of change is positive is the same as increasing, which is where the graph is going up. Okay, so I need to be looking back on the graph to see where the function's increasing. But I remember that I've already answered that question, so I'm going to translate the, you know, statement into pre-cal, or, you know, what we know as pre-cal, and then we're going to go and use our result from earlier. So we're translating that to rate of change of f is positive when f is increasing. And then, well, we already answered that question. That's when we're running from -2 to 0 and from 4 to infinity. Okay? We make this easier on ourselves, not more difficult. Okay, because I know that the language here is that's the challenging part. You've already found where the function's increasing. We don't need to go back to the graph and hammer that home. When is the rate of change of f negative? Well, the rate of change of f is going to be negative when f is decreasing. So that's going to be what I wrote in purple, and I'm just going to write it the exact same way. X is less than -2, and also x between 2 and 4. Okay. And then the rate of change of f is increasing. Okay, that's when the function's concave up. Okay, I'll even go show you. All right, there you go, yeah. Rate of change increasing, concave up, rate of change decreasing, concave down. So I go, I look, I've already answered that question. I already did that analysis on the graph. And if you need to be reminded why the graph is concave up between, you know, or when x is less than 0, when x is greater than 3, then just skip back a couple minutes to when I was writing in blue, and then you'll see what I'm talking about. Okay, so x less than 0, x greater than 3. And then rate of change of f is decreasing when f is concave down. I didn't translate that. All right, that's a little better. So when the rate of change of f is decreasing, that means we're looking for concave down. Okay, we had that up here. That's in green, 0 to 3 only. And, but, again, that's where the graph's frowning. Okay. Now, again, we've got a graph of a function, and it says the extrema and points of inflection of g all occur at integer values of x. Okay, so that means it's the whole number. And, all right, so local extrema. Okay, you need to know that that means maxima and minima. So there's one there, here's one over there, and a third extreme value. Okay, there's 3 of them. Okay, so that would be x equals -1, x equals +1, and x equals 5. Circle the points of inflection on the graph of g. Looking for where, the graph of g has an attitude change. I don't even know if I'm going to write anything there. I'm just looking for where it changes. Okay, it was smiling at first, right? It looks pretty happy. But then, eventually by the time it gets to this maximum, it's frowning. And then eventually it's smiling again. So that's, like, by my count, that's at least 2 changes in attitude, right? If it was happy and it got sad and it got happy again. So that's 2 different times. Okay, it looks to me like that's where one's happening. And then also, let's see. It's either 2 or 3, but let's look closely. I cannot tell. I think if you said 2 or 3, if this is like a quiz or a test or something, we'd be cool with either. But I don't know about that. I do see that little kind of bump in the graph, but I'm gonna go with 3. I just feel better about that. Okay, so circle the points of inflection on the graph of g. I just did that, but just, to add on, I'm gonna list that those are at x equals 0 and x equals 3. All right, so where is g both positive and decreasing? Okay, so we're looking for above the x-axis and decreasing. I'm not going to worry about trying to spend too much time translating that because I'm assuming that the increasing, decreasing, concave up, concave down is the language that you're most familiar with, and it's the rate increasing, rate negative, all of that stuff that I'm going to need to be a little more careful on. All right, so I'm looking for both positive and decreasing, and that feels like that's going to be right in there. Okay, I think, oh, wait, no, also here. It's very easy to be tricked by that arrow. It happens in calculus all the time, and the arrow is going off to the left, and you're like, oh, no, it's increasing over there. But it's not. As I move left to right, the graph's going down, okay, and it's positive over there. So that's a place where it's both positive and increasing. Okay, so that's where x is less than -1, also when x is between 1 and 4. I will point out that if you wanted to make these not strict inequalities, that would be totally all right. Yeah, I mean, maybe the 4, if you're like, it's not positive there, it's not negative. And what I'm also trying to say is that, like, we're not trying to argue with anybody over endpoints of intervals. That's not what AP Precalculus is all about. And so we're not going to get into it. All right, where's G both increasing and concave up? So that's going to be increasing while smiling. And I am going to draw a picture of what I'm looking for before I go looking for it. So it's increasing while smiling. So that would be, about like that. Uphill and going uphill happily. Now with this, I'm gonna start at this minimum. It looks pretty happy through here, and I just need to be aware, okay, I'd already labeled the point of inflection, that's probably where the happiness is gonna stop and where the sadness is gonna begin. Okay, and then I'm looking for increasing and concave up. That's over here as well. All right, so that's going to be from, should just label these each time, -1 to 0 and 1, 2, 3, 4, 5 to infinity. -1 to 0 and 5 to infinity. All right, now where's the rate of change of g positive and decreasing? This is where we have to be careful. This is the type of one that I know y'all are needing support on. Okay, so what we're going to do is we're going to unpack the sentence. like it's a literature class. So rate of change of g is positive. That's where the function's increasing. Go back to the grid, go back to the definitions in the notes book, or whatever you're going to do to remind yourself of that. Okay, but then rate of change is decreasing, because if we say, where's the rate of change of g both positive and decreasing, that means that the rate of change of g is positive, and it means the rate of change of g is decreasing. That's an important point to make. Okay, and then you go back and you look at that in the table or whatever, and you see that the rate is decreasing anywhere where the function is concave down. So we're looking for increasing and concave down. But we know what that looks like. Okay, increasing is where we're going up. Concave down is where the graph is sad. Okay, and I kind of drew it there, like it started to decrease after a second, but it's looking like something like that little arc. Okay, so I'm going to search for that up above, and I'm probably going to clear out that highlighter I was just using. All right, so increasing and concave down. Okay, see the graph is frowning through here, also increasing, that works. And then, okay, that's the only, that center region between the two blue circles, that's the only place where the graph's concave down. And of that, the only place where it's increasing is the place I've already highlighted. So there's no place else where this graph could be both increasing and concave down. There's nowhere else where it could be increasing at a decreasing rate. That's another way we could have said that. But the rate of change is positive and decreasing. I don't know if I said it, but that's from x equals 0 to x equals 1. Right, I know I've been writing all my answers in inequalities or interval notation, but I just do want to point out that I would be perfectly fine if you said x equals 0 to x equals 1 in words like that. That would be just fine. Where is the rate of change of g positive? Okay, rate of change of g is positive. I just said that up there. That means it's increasing. So I'm moving from left to right on the graph and looking for where I'm going uphill. And that's the eraser. Okay, I'm just going to be going uphill here, through the point of inflection and up there, and after x equals 5. Okay, so that's going to be from -1 to +1, about, and 5 to infinity. Then g is, when is g decreasing at an increasing rate? These are the ones we got to be careful on. These are very tricky. Okay, so g is decreasing. That's what we're saying. And then we also are looking for when the rate of g is increasing. Okay, now rate increasing, that means concave up. Okay, so I'm looking for, on the graph, where is this thing decreasing and concave up? And I'm going to draw a picture of what I'm looking for. Decreasing while smiling. So that'll be about like that. And we'll see, I think I know some places we have that. Decreasing while smiling, that would be through here. And okay, it goes up to that maximum at x equals 1, but it's increasing. And okay, but after that it starts decreasing again, but it's frowning until the point of inflection. When we're looking for, it's decreasing and smiling. So decreasing at an increasing rate, that's going to be down here. So from -infinity back to -1, and then from 3 to 5. Right. And then, all right, when is g negative with a rate of change that is negative and decreasing? All right, I will admit this is one that we were sitting around and putting the finishing touches on this homework, and we were looking for something a little bit different. This isn't something you're gonna have to worry about on the quiz, the test, this triple thing here, but negative with a rate of change that is both negative and decreasing. I'm gonna have to draw a picture of this, okay? G is negative means that the graph is below the x-axis. Rate of change is negative means that G is decreasing. So I'm going downhill. And then rate of change is decreasing means graph is concave down, so it's gonna be frowning. So it's gonna look like that. So I'm looking for places where it looks like that below the x-axis. Let's look at the places that are below the x-axis. And to remind you, I'm looking for that. Well, I have that little bit of decrease there, but as that's happening, if I went in, it's smiling, right? This is not negative decreasing at a decreasing, or yeah, negative with a rate of change that's negative and decreasing. Okay, that doesn't ever happen is the answer to that one. So I'd say never or no. Okay, but don't worry. But if that one didn't stick with you, don't worry. Let's keep moving. Okay, so the graph of y equals h of x is shown in the figure. The extrema and points of inflection of h all occur at labeled values of x with like a, b, c, d, and e. And I will also point out x equals 0. Okay, that's a value we're going to need to use. So find intervals on which h is negative and increasing. Okay, we can do that. Negative and increasing would be through here. So I think that's going to be from 0 up to e. Write it however you're going to write it. Doesn't matter. Find the values of x for which h of x is greater than or equal to 0. Okay, well, maybe I'll actually switch over, do that in red. It's equal to 0 here and there and here. Okay. It's greater than 0 where the graph's above the x-axis, so that'll be over here. This is kind of a weird solution, but we've already had this happen once on this video. It'd be a to c. And then also x equals e, because at x equals e, h is equal to 0. All right, find the intervals on which h is concave up. I'm going to get rid of these annotations. Okay, concave up is where the graph is smiling. So not at the beginning, okay. I do see it's smiling here in the middle, but then by the end it's frowning again. So all right, I'm looking for this spot in the middle. And they said that all of the points of inflection and extrema are labeled. Okay, so I'm thinking that this is going to be one of them. So it looks like the graph is frowning to the left of C and smiling to the right of it. And then I think D is going to be the other one because it's labeled and it's not an extremum, so it must be a point of inflection, right? So I'm going to say, okay, concave up is from C to D. Then we can find the intervals on which the rate of change of h is negative. That's going to need a translation. All right, rate of change is negative. The rate of change of the function is negative. The function is decreasing. So the function is decreasing from here to there, and then after e, so that'll be through here and there. So that's going to be from b to 0, and then e to infinity. Yeah, and x is greater than e. All right, now find the intervals on which the rate of change of h is decreasing. Okay, that's, again, going to need a translation. All right, so go back and look at that grid or whatever notes you've got. Rate of change decreasing, that's concave down. So I'm looking for where the graph is frowning, and I feel like I may have already done that. No, but I found where it was concave up, so that might be helpful. So I'm going to get rid of some of this stuff here. I got my points of inflection labeled, and so I'm going to say, all right, concave down is where the graph is frowning, and it's there, and then D is where the concavity changes, so I know it's going to be through here. So, less than C, greater than D. Increasing at an increasing rate, okay, we know what H is increasing looks like. It's going uphill. Rate is increasing. That's going to be where the graph is concave up. Okay, increasing and concave up. I might even draw a picture of that. Looking for that piece of graph there. And okay, yeah, this is gonna be relatively brief because it's only concave up between C and D, and increasing and concave up would be right here. So that's 0 up to D. Okay, and then how many points of inflection does the graph of H have? Okay, I guess I just happened to label them. Okay, it's C and D, so that's gonna be 2 of them. And then I think, let me look at this. Yes, this is going to be the last page fit. And so now we're going to get into some tables, and I think that'll be healthy for us as well. The reason that we're not approaching this from an algebraic perspective is that determining increasing, decreasing, concave up, and concave down behavior of functions algebraically is, well, basically that's the first half of calculus AB. And so we're obviously not going to be doing that, this being AP Pre-Cal, and so we're going to really focus on the graphs and the tables and hopefully develop a good intuition going into AP Calculus next year. I have some doubts, but you know, that's we're going to give it our best shot here and try to understand it the best we can, okay, without using the derivative, of course. So for each of the tables here, we're going to determine if the function is increasing or decreasing and determine if the rate of change of the function is increasing or decreasing. Okay, so I think what I'm going to do is I'm going to actually set up like a grid, basically. What we're going to do is we're going to look at the differences. In fact, I actually think, yeah, I mean, all of these tables are going to have x being -2, 0, and 2. But I think it would be best just to look at the first order differences and the second order differences, and that will be, you know, as long as the table is arranged, you know, where x is increasing or going along, you know, increasing x, we can actually just look at the sign of the first order and second order differences, kind of like we looked at the values of the first and second differences in algebra 2, but let's just get to it. So I'm over here, and I don't want to snap to shapes anymore. I'm going to be subtracting 1 and then subtracting 3. Okay, so I'm seeing negative rates of change from that first order difference. And so that's negative rate of change is where f is decreasing. And the rate of change of f, we're going to test that by looking at how, whether it's increasing or decreasing. We're going to look at the rates of change and see, did they increase or did they decrease? And so if I went from -1 to -3, that was subtracting 2, that's a negative number. So the rate is going to be decreasing. So f is decreasing at a decreasing rate. Okay. Over here, f increases from 4 to 6, that's adding 2, and 6 to 10, that's adding 4. Okay, so I see a positive rate of change, so f is increasing. Then I look at the second order differences, and you know, I'm realizing I probably should have used some color here, so actually I'm gonna do that real quick. Alright, so I'm just saying, alright, I'm going to do the first order differences in red, and that's going to tell me about whether f is increasing or decreasing, and then the second order differences in blue will tell me about whether the rate of change is increasing or decreasing. So, alright, so from +2 to +4, that's an addition of 2, that's a positive number, so the rate is increasing. And we would say that f was increasing at an increasing rate. Right, let's keep it going. So 7 down to 4 down to 3. Right, so first I subtracted 3 and then I subtracted 1. Okay, I'm seeing a negative rate of change, so that means the function is decreasing. Or you could be like, I'm not going to think that hard about it. Look, it's going down, it's decreasing. That would be totally fine. Then we're going to look at -3 to -1. And we're going to say, okay, to get from -3 to -1, I have to add 2. It's a positive number. Okay, and if the rate increased, that's what we're saying, the rate is increasing. Okay, and then 5, 7, and 9. Okay, I like this one. So this one, we start off, we are adding 2, and then we see we're adding 2 again. And this is unchanged. Okay, so that means we're sitting on a linear function, right? If we see a constant rate of change, that's a linear function. And so I've got, let's see, I'm going to say f is increasing at a rate that is constant, or at least appears to be from the table. And so that's where we're saying, what was I thinking? Yeah, it appears to be linear. That doesn't necessarily have to be. With additional disclaimers about the numbers of points of inflection or extrema or something, we could make that certain. That's what I was thinking about there. But that's not important. Let's keep moving. So number 5, the table below gives information about the rate of change of the function f of x. All right. So I think, I think on a table like this, I hadn't really thought about this. After I decided I was going to be like really, really intentional about how I was setting these questions up. I think what I'm going to do here is I'm going to use 2 different highlighter colors. I'm going to go over here and I'm going to say, all right, rate of change is negative, then positive, then positive, then negative. Okay, and then I'm going to go in and I'm going to look at how the rate of change is changing, and I highlight that a different color. And then I don't have a whole lot of room over here, but I'm going to translate this to rate of change negative, that means decreasing, and rate of change increasing, that means concave up. And I might even draw a picture of this, and if that's what your first thought was, like to try to sketch this graph, that's what you should do, totally. That will help you. You just gotta be careful. It's gonna be a weird looking graph. It's gonna have some like sharp edges on it. I don't know what's going on there, but no, this doesn't look good. All right, when the rate of change of f is positive and increasing, the function f will be both increasing and concave up. And when the rate of change of f is positive, the function, so I'll say the function's increasing. Not very good. So increasing. And when the rate itself is decreasing, that's going to be concave down. And then the last one, when the rate of change is negative, that means the function itself is decreasing. And if the rate is increasing, that'll be concave up. Okay. Now, when is f increasing? Well, to translate this kind of backwards into rate of change, increasing is where rate is positive. So that would be here and there. So from 4 to 6 and 6 to 8, we could say from 4 to 8. That would be fine. And I could say, all right, well, when is f decreasing? That's going to be when the rate is negative. So we can go into the table and say, all right, I'm seeing negative here, negative there. So that's when x is less than 4 and when x is greater than 8. Okay. When is the graph of f concave up? I'm going to need another color for that. Now, to translate concave up to, in terms of like the rate, that would be where the rate is increasing. So I'll say, all right. So I see rate increasing here, rate increasing there, and another one over here, rate increasing. So I'm going to say, all right, from x less than -4 and or less than 4 and 4 to 6. Okay, well that's just where x is less than 6. And then also when x is greater than 8. Okay, because that's where the rate of change is increasing. That's what it means to be concave up. So the graph of f is concave down, well, pretty much every other time. So but we're looking for where the rate is decreasing. That's going to be right there. That'll be 6 to 8. Right. At what values of x does the graph of f have a point of inflection? Okay. Well, remember, a point of inflection is a change in concavity. So that would be where we change from green to orange or orange to green. So you could see that it happens right there at 6. Right as we're ending 4 to 6 and beginning 6 to 8. That's at x equals 6. And also at x equals 8 as well, because we're going from rate decreasing to rate increasing. That means from concave down to concave up. I actually think changes concavity would be the easiest to see if I went over and used the highlighter and said, hey, I went from concave up, wait, whoops, not there, right here, went from concave up to concave down. That's a change in concavity. And then I'd change from concave down to concave up again. It's another change in concavity. So I've got them at 6 and 8. At what values of x does f have a maximum? Okay, well, remember, a maximum is where f goes from increasing to decreasing. Increasing to decreasing, okay, we would need to look at the rate of change, whether it was positive or negative, but we'd already kind of translated that up above. So I'm thinking, all right, I was decreasing, and now I'm increasing. I kind of forgot what I was looking for. Am I looking for a maximum or a minimum? Maximum is increasing to decreasing. So that happens from the third to the fourth. So that's going to be at x equals 8. And then minimum would be where we change from decreasing to increasing. Oops, oh, whoops, I'm out of room. Okay, my handwriting's getting a little sloppy and a little tired. So f is having a minimum where it went from decreasing to increasing. Okay, so that's going to be at x equals 4. The rate of change went from negative to positive. Yeah. So it's x equals 4. And now, to cap it all off, I'm gonna sketch the graph here. Okay, so we went, let's see, I don't have much room to do it. I know what to do. All right, so I'm thinking I'm going to start by drawing something that's decreasing and concave up. And it really doesn't matter, how far up or down we go, because we didn't have anything about whether f itself was positive or negative, so I'm not even going to draw in an x-axis. I might label the points with their x-coordinates, but that'll be it. Then I go to increasing and concave up. So the concavity did not change. Okay, so I'm still smiling, but now I'm increasing, and that's that minimum we were talking about. Okay, and I feel like I could draw that a little bit smoother, so, whoops, I did a lot of small ones, but, all right, now I'm increasing and concave up from 4 to 6. Okay, but then I start increasing while concave down. Okay, so I've got to have had a point of inflection, so I'm starting to frown there. I should probably mark where I made that happen. Increasing and concave down, and then suddenly it's going to be decreasing and concave up. And actually draw this a little differently, with a little more steepness. So it's definitely frowning in there, but I'm not going to make it look like it's coming to a zero slope or anything. Okay, and then it's going to be decreasing while concave up, so it's going down while smiling. And this is going to be, it's going to be a sharp corner. Yeah, maybe I can do a little better than that. All right, so there you have it. My best sketch of what I think this graph might look like. And that's, yours may be a little bit different, but overall, your sketch should look more or less similar to this. All right, that's all I got for this video. Thanks for watching. Really hope it helped.